Hello. Tonight I'm going to talk about IPv6. IPv6 addresses, and you'll know how to deal with the IPv6 address, why is it needed, and then we'll how to configure IPv6 on a router. We'll do that on different videos. Actually, we'll learn how to look at how the router looks up the routing table and all that good stuff. But we'll do that on a different video. In IPv6, why IPv6 and what do we have? In about 1991, even after using private IP addresses and the protocol NAT to conserve IPv4 addresses, we were still running out of IP addresses. IPv4 had a 32-bit number, and 2 to the 32 is approximately 4 billion addresses, and not even close to 4 billion addresses are being used for the public to communicate with each other. So, if you remember IP addressing worksheet number 3, we talked about the IPv4 classes, the 3 classes A, B, and C, and we were limited to a few million addresses. But now everyone is needed an IP address. So at any rate, they decided to get together and expand this IPv4 address so you can get more addresses. So they started working on IPv6 and to set up a much larger number of IP address available so you can actually deploy them to much more number of hosts. As they were working on, then they decided, as they were working to expand this IPv4, they called it IPv6, IPv5, and in the meantime, there's the Internet Corporation of Assigned Names, or the IETF, I should say, said the Internet Engineering Task Force. They said, why don't we just solve all the issues that IPv4 had? For example, we don't really need broadcasting, so IPv6 now doesn't even have broadcasting. No need for that. Let's make sure it's secured. All the problems that IPv4 had, they wanted to improve the configuration on the devices. Let's make it automatic. No need for DHCP server. And so they started working on the features to improve the IP addressing when it came, not only increasing the number of addresses. So by 1996, it was ratified into IPv6. So IPv5 and 6 got together, and now everything is in IPv6. IPv6 now, instead of having 32 bits, it has 128 bits, which as far as we are concerned, 2 to the 128 is an extremely large number. You can go on the internet and calculate to see how many available addresses that you can have with a 128-bit number. So it's very, very large. We're not going to run out of IPv6 addresses for the foreseeable future, so you don't have to worry about it. So that's number one. We're not going to run out of IP addresses. And the way they broke down the IPv6, here are the advantages. If someone asked you, why do we need to work with IPv6 instead of IPv4? Number one, pretty much you do not need to do subnetting. So when we work on that subnetting in IPv4 on the last video, don't even have to worry about that, because there is one portion of the IPv6 is dedicated for a subnet, and you just have to put in subnet 1, subnet 2, and so on. You don't have to break up anything. That's number one. Number two, it has efficient route summarization, so you can summarize the network much quicker. No need for NAT. Devices are going to be able to have a global address, so from inside the LAN, and they can go out directly to the internet using their global address. So no need for translations. You don't have to stop at your gateway, get translated to go out, get translated with, in other words, go get a global address to get on the internet. So no need for that. You can go in and out of your network very, very fast. So that's good for streaming videos or voice over IP. Any real-time communications, you want to use IPv6. Since you can go in and out without having to be translated, therefore IPv6 must be secured. Everything is already built in IPv6. I'm sorry, IP security. So everything is really encrypted already before you transmit your data outwards. So it's more secured, no need for NAT, no subnetting is required, efficient route of summarization, building QoS, which means you can have a much better setting priorities, which packet can go first and which can go next and so on. Better flow control, less labels that are stamped on the IPv6 packet, so the packets move much quicker. Okay, now let's take a look at the IP address itself. So those are the benefits of IPv6. The IPv6 address is typically written in hexadecimal number. Here's an example of it. Let me just blow this up so you'll see what I'm talking about. These are called hexadecimal. Each one is separated by a colon, and so each hexadecimal, which is a 16-bit number, is written in hexadecimal number. So each digit is really 4 bits. So 4 times 4 is 16, and we have 8 hexadecimal, and so you have 16 times 8, you get your 128 bits. Okay, so that's typically how the IP address is written. There's going to be a lot of zeros, so I'm going to show you how to write the IPv6 address in a more concise form. Okay, so we'll talk about that later on. So here are, let's take a look at the actual IP address and how it's broken down. Okay, so here's a typical, the first 4 hexadecimal, the first 12 bits of this number is always from the registry, deciding, the whole world is broken up into 5 areas, into regional internet registry areas, RIR. So for North America, and that includes the United States and Canada, that's why you see a number 2 always for the global address. So the first 12 bits in your IPv6 will indicate which part of the world you are in. Are you in North America, South America, Europe, Asia, and so on, those 5 areas. From 12 to 32 is going to identify the ISP. So if you are in the United States, you're going to have the first 12 bits indicate that you are within North America. And let's say Verizon will be given a code, and that code is going to be between bit 12 and bit 32. And then Verizon, let's say, gives your site, your company, a number that will indicate who you are in that ISP. So the first 3 hexadecimal is going to indicate what part of the world you are in. That's the registry internet, the regional internet registry. It's going to say also who is your ISP and which company you are in. So that's automatically given to you, the first 4 hexadecimal. The 4th hexadecimal, just this number right here, is going to indicate which subnet. So this is left empty. So when you get, the first 3 hexadecimal, you just go in here and type, this is going to be my subnet 1, that's for LAN A, and you put number 2 for subnet 2, subnet 3. Of course, they share the first 3 hexadecimal, and you don't have to do any subnetting because they already, the 4th hexadecimal is reserved for subnetting. So the first 4 hexadecimal, which is the first 64 bits, indicates again which part of the region the world you are in, who is your ISP, what company you are in, and the subnet in that company. That's what those first 4 hexadecimal. The last 64 bits, the last 4 hexadecimal, is going to be your host address. What we call it the interface ID number. Okay? Alright, so this is a little bit more explanation. I left this worksheet up in Docshare so you can take a look at it, read it into a little bit more details. And by the way, so how do we get your, here's another thing I want, how do we get the last 64 bits in your network address? So this is what your computer does in the old days. What they used to do is they go to your NIC, they grab your MAC address, and what they do right in here between the OUI number and the serial number, they go in and they put in the number FFE. So they'll take the 48-bit number, your MAC address, insert the number FFFE in the middle, and then you'll have the 64-bit number. And of course, all you got to do is you got to change this number right here to increment this by a 1. I don't think I did that here. Anyway, this number will be inserted and used as your yeah, I didn't say that right here. You insert a binary 1. But anyway, you insert that as your interface ID, and that will be used as your host portion of the IP address. So that's called the EUI method. Okay, to identify your host address. Or you can actually, now what they do is they can randomly just pick a number and make sure no one else has that number in the network address. But I discussed that in the other videos when we were talking about the lecture. But we can use your NIC by just inserting FFE in the middle. Use your NIC MAC address as the host. And that's how you come up with your host address. You don't even have to add, put in numbers for your network address. So it's much, much easier to configure. Okay, let's take a look at the different types of IPv6 addresses. Well, let's look at the Unicast address. Every device will be given a linked local address. A linked local address, by the way, IPv6 allowed an interface card to have more than one IPv6 address. So you could have multiple IP addresses assigned to one host. For example, the first address is a linked local. Any address that begins with FE8, FE9, FEA, or FEB is called a linked local. The first 10 addresses like this. So the linked local address is the one that you use to communicate with anyone inside the LAN. You cannot use that address to go outside your LAN. If you need to go outside your LAN, you're going to need to use either a unique local or your global address. But a linked local is the one that you use to communicate inside your LAN. It starts with FE. So everybody that's inside a LAN will have an address that starts with FE. For example, let's say I have FE1, another guy will have FE2, FE3, and so on. But no one else should have the same linked local address as long as you are inside the LAN. Somebody else in a different LAN will have probably the same configuration as your LAN, because they can't use these linked local addresses to communicate outside. So you can have the same linked local address on two different LANs. Okay? Now, unique local is something similar to the private IPv4 addresses in IPv4. The private IP addresses in IPv4, which means you can subnet them and you can communicate outside your LAN, but you cannot access the internet with a unique local address. A unique local address always starts with FC or FD. Okay, just remember that. The global IP address is the one that you use to access the internet. So in our case, anytime it starts with 2 or 3, you know it's a global address, which means it's the address that you use to access the internet. Typically, what I do when I'm configuring devices, and you'll see that in the next video, is you always assign a linked local address to the host, and you also give them a global address so they can access the internet and go outside with it. Okay. A multicast address. A multicast address always starts with FF. Since we do not have any broadcasting with IPv6, that's another benefit of having IPv6. We're going to use a multicast address to simulate a broadcast address. So there's no special address with .255 to broadcast to everyone in the network. So multicast means that you're sending a packet to multiple users in a LAN. So if your address begins with FF021, that means this is similar to broadcast address. So FF02 colon 1, that sends the address to everyone in the network. FF02 colon 2, that's to all routers. FF02 1 colon 1 at the end is for a DHCP server. So everybody joins FF02 colon 1, then that will simulate a broadcast address. So if anyone wants to send a broadcast message to everyone in the LAN, will have FF02::1 stamped as the destination IP address on the packet, and everyone in the land will get it. But that's still a multicast address. Okay, we'll talk about multicast addresses in a different course, but it's a little bit beyond the scope of this course. Any cast address means IPv6 can assign host with the same another address that is the same, and this is typically used for DHCP server. So if somebody's looking for someone that has a specific IP address, multiple users can have it. That's called an anycast. A loopback address. This is similar to the 127.0.0.1 to test the local loop, the local TCP/IP stack for connectivity. So if you type ping::1, you're pinging the TCP/IP IPv6 stack. If you get an IP address with all zeros, that means that's something that you don't have an IP address assigned. And here's a whole bunch of different IP addressing, special IP addresses you should be familiar with. Anyway, take a look at this worksheet. It has a lot of details, and it talks about the configurations and a whole bunch of other good stuff I put up here for you. All right, we don't have to go into details in all of this, but the other thing that I wanted to show you is how to write an IPv address in a concise form. So let's take a look at an example. Let's say an IP address starts with 221.0.0.1 colon. Well, let me bring this up so you can actually see what I'm doing. So here's a typical address, 2001, 08, BF, colon, ACAT, colon, 0000, 000, oops, put another colon, 0000, colon, 0032, 0, let me see, 1, 2, 3, 4, 5, 6, so we have 200,000 and another 0001. Okay, and this is slash whatever 128. So you have 1, 2, 3, 4, 5, 6, 7, 8 hexadecimal. Now, you don't want to write this because there's a lot of zeros. So here's a rule on how to write an IP address, IPv6 address in a concise form. Rule number 1, eliminate the insignificant zeros. Any zeros to the left of a number, get rid of. So that's rule number 1. So this 0 has to go. If you have 4 zeros, just remove 3 of them. Here's another one. Remove that. I can remove these 2. These 3 zeros are significant because they are to the right of the 2. But these 3 zeros are insignificant. So you'll remove them too. Now, wherever you see zeros that are next to each other in consecutive order, you can remove them and just leave an empty column between them. So these 2 zeros get removed, and you just leave empty column. And that's how the number is. Why you can do that? You've got to be able to read this address and construct the IP address back. So if I have 1, 2, 3, 4, 5, 6 hexadecimal, I know this empty colon represents 2 zeros because I have to have 8 hexadecimal. Okay? So if you have, let's do another example. So let's say I have 2001 and I have 000, 000, 000, and 000. Let's say I have 52C0, and let's say 0000. Let me see, I have 1, 2, 3, 4, 5, 6, 000, 0. Let's say I have 0, 2, D, E, right? Okay, so let's follow the rule and see how we can write this in a concise form. So the first thing is you get rid of, again, the insignificant zeros. So you remove 3 zeros here, remove 3 zeros here, remove 3 zeros here. This zero stays, but you gotta remove these 3 zeros and remove these 3 zeros, and you gotta remove this 0. Now, when it comes to removing the consecutive zeros to write an empty colon, you can only do it once. So should I move these 2 zeros or should I move these 3 zeros? So you remove the most, remove these 3 zeros. So you remove them, and this will be address. These have to stay. You cannot remove them, because if you remove them, then you won't be able to you won't be able to reconstruct the full IP address. Okay, so you have, now I know I have 1, 2, 3, 4, 5. That means this empty colon represents 3 zeros, right? By the way, if you have, for example, for some, in some instance, let's say, let me just rewrite this. Let's say you had the number 4, 5 in here, right? And you have 2 empty 2 zeros here and 2 zeros here. You can choose to either get rid of this or get rid of this. It doesn't matter, but you cannot get rid of both. Is that clear? So this is written correctly, right? Or this is also correct. Okay? But this is definitely incorrect. This is not good. Why? Because if you have 1, 2, 3, 4 hexadecimal, right? Now you have 4 zeros. Is it 3 zeros on this side? 1? Is it 1? Is it 3 on this side, or 1? Is it 2 and 2? You don't know. So you won't be able to reconstruct the IP address back if it's written with 2 empty colons. That's the idea. There only should be 1 empty colon when you are rewriting the IP address. So let's assume that it's this. So if somebody gives you this and says to you, can you rewrite the full format of the IP address? Well, you could say, all right, I have 1, 2, 3, 4, 5, 6 hexadecimal. So that means this empty colon must be 2 because we got to have 8. So you write 0, another colon 0. And then each hexadecimal has to have 4 digits. So this has its 4, this one has to have 4, and then this one has to have its 4. This one has 2, so you put the 2 insignificant. This one has its 4, this one has to have 4, and this one has to have 4, and the last one just needs a 1. And there is my 64-bit written in hexadecimal number. Alright, so this is really how you can convert IPv6 from a full format to a concise form and vice versa. Okay, on the next video, like I said, I am going to show you how to configure IPv6 on our routers. Until then, I'll see you and keep up the good work.